The software development field is pretty big and there are different roles in that field. And every role translates to a different job description within software development. So in order to understand all the different roles and their responsibilities and how each one of those roles fit into the whole software development and the maintenance lifecycle, let's actually go through each one of them, thus building the overall image of how the whole process actually works. So if you're one of those roles, either a developer or a system administrator, DevOps engineer, whatever it is, you probably have a good overview of your own department or your own responsibilities. However, it's also interesting to see the overall big picture of all the IT processes. And this is especially important when we're talking about DevOps engineering, what the roles and responsibilities and tasks of DevOps engineer is, because sometimes it can be a little blurry and unclear, and there are also many discussions about this topic. So the purpose of this video is to clarify all doubts, to make your knowledge much more solid and draw a big and transparent picture of how all these different roles in IT kind of fit together and form the overall cycle. So that instead of half knowing some of the concepts, you really understand each of those concepts and have clear examples and specific use cases associated with those. So let's get started right away. First, let's look at the very, very high level picture of overall software development. This is the most common use case where we need all these different roles. For example, an application that is developed by a big company. In this case, let's take an example of Facebook. It is a pretty complex application and it will probably require all of those different IT roles and responsibilities in order to make the whole Facebook development process possible. So first, let's start with the programming. So Facebook is basically a software, an application that needs to be developed by developer team. So on a higher level, developers code the application in various different programming languages. Developers work in teams. If it's a small application, then you would have one team per application. If it's a huge application like Facebook, you will have multiple teams probably per feature. So for example, a Facebook Messenger will have its own development team. Maybe the business side or the business features of Facebook application will have its own team, and so on. And these are the people who write code for creating new functionalities in the application. But also, if something doesn't work in the application, they also fix those issues. So once the development process is done, so to say, the feature is developed and it's functioning, the next step is to test the application. If you have an existing complex application where you add new features and fix bugs all the time, of course, it's important to make sure that the code changes didn't break the existing functionalities. So that when Facebook releases a new version, you can still log in, you can still chat, upload pictures, and everything else works as well. And the testing is done at various different points, all right? The developers, they test the code themselves, and there are also people that manually test new features and bug fixes, etc. However, you can imagine how much effort it could be to test an application as huge and complex as Facebook, especially if you have so many features and you are adding new ones all the time. So because of that, not to have this repeating testing process, there are automated tests. So instead of people testing the application, there are programs that are testing the application. So it's a code that tests the code, so to say. So once the testing process is successful, the application can be released. So let's say a new feature was added to Facebook, developers finished the development, they tested it locally, they checked that everything works in the code, nothing is broken, then a bigger layer or a higher level testing is done to make sure that nothing was broken and everything works in combination. The automated tests ran, and now it's time to show that new feature to the users, right? So kind of roll it out to the whole world as a new feature. And that process is basically the release process of the application. And in order to release an application, you have to build that application, meaning package it into a compressed code and then run it on servers, right? Of course, in case of Facebook application is already running on multiple different servers. So basically when a new feature gets added, that feature needs to be added to that running code. So basically the application needs to be updated or upgraded. And this is where the part of operations comes in, right? Operation is a team, or IT operations is another part of the software development and delivery lifecycle that is in charge of running software in production. So in this case, the IT operations will be responsible for taking that new feature and running it successfully on the existing production servers so that new users can get access to it. So now you probably already imagine there is responsibility area for developers and for IT operations. So developers do their job and they kind of hand it over to the operations saying, it is ready, please deploy that. And part of that deployment process is, as I mentioned, integrating that new feature into the new application. And the challenge here is, of course, from the operations standpoint, that the application doesn't have a downtime when such upgrade or addition to the application happens. Meaning, if Facebook releases a new feature, you as a user don't want to be sitting in front of a laptop and suddenly Facebook doesn't work anymore. You have to wait for 5 minutes and a new version pops up in your browser. So that will be a very annoying situation if every time a new feature got added to Facebook application that happened. So instead, it is very seamless. You don't even notice as a user that an upgrade of the application happened because there's no downtime. And that part is, as I said, responsibility of IT operations team to make sure that the upgrade doesn't cause any downtime. But also, operations team has to make sure that under no circumstances a downtime of the application happens. This other use cases could be if the servers fail, for example, right? Could happen very often because it's just the hardware, it can break, something can happen to it anytime. So whenever some of those servers where the application is running basically die or break or something happens to them, the application must still continue to run. And operations team is responsible for that. Another thing that operations team has to make sure is that the application is able to handle millions and millions of requests. In case of Facebook, of course, there are loads of users using the application every day, so the application has to handle that traffic. And again, operations team is responsible for that. How does all this happen? How do they make sure that the operation has no downtime and is load resistant and keeps running even if millions of people access it at the same time? Basically, they make sure that the underlying infrastructure is working perfectly, and they make sure that the performance of the IT infrastructure is always at its best. And that's how software development and IT operations teams and their responsibilities completely differ from each other. So they're both responsible for their different areas. But also, you probably also notice that they need completely different technical knowledge and knowledge of completely different tools to do their jobs. Software development side is knowing programming languages, testing frameworks, databases, and so on. On the side of the IT operations, it's more the operating system, mostly Linux, command line tool, scripting, meaning writing automated scripts for the operating system and the servers, monitoring tools that allow them to monitor if something happens to the IT infrastructure, and so on. So completely different tool set. Which means that these two jobs or areas of responsibility that is part of the same process of software development delivery, so to say, have completely different competencies, skills, and know-how. Yet they have to communicate with each other so that this handover of here is my application which I developed and tested, it is ready to run, please run it on the production system. This handover has to happen very effectively and smoothly, and that will require a very effective communication between these two roles. The reality is, because these roles are so different, there is basically no interface between them. So the communication is very difficult between those two roles to make this process effective. In reality, how this works is that developers develop the application, testers test it, and basically it is ready to be released on the production server or to be handed over to the operations team. Releasing and deploying that application and running it by the operations team mostly requires some kind of instructions because that application has some dependencies, it needs a certain configuration. For example, it needs some environmental variables, it needs a space or a folder on the system to log to. It could be any type of configuration that the application needs, or may need a database, for example, with a certain configuration. So whatever it is, operations team has to prepare the server and the environment where the application runs before deploying that application. So in traditional software development process, in this ineffective process, what happens is the development team documents the instructions of how to deploy the application and then hands over the application, the built artifact of the application, together with the instructions of how to deploy that to the operations team. Operation team tries to follow the instructions to configure the application, to prepare the environment for deploying it. Usually and mostly this doesn't work because either the instructions are not clearly stated or it's just too much and something is missing because someone forgot to put something there and so on. So if this happens, the operations team will have a very hard time running the application and it may take weeks to make that happen. And because of that, many companies have release cycles, so to say, in their application development process that takes weeks or months. So whenever a new feature needs to be released, so to say, to the public, to the users, it may take up to a month or maybe multiple months for the operations team to actually make that happen. And because this is a big problem, a solution was needed for this miscommunication and solving the issue of having two completely separated, unrelated roles that couldn't communicate with each other or had a hard time communicating with each other and working with each other effectively. And that solution basically was the DevOps culture. Eventually, DevOps was just a concept, just a culture, a way of working between the developers and the IT operations. Now you probably already know DevOps engineer as a job title, but initially it was just a way of working to make sure the developers and IT operations found a common language to communicate with each other. And that culture eventually became its own role and job description because it started to encompass so many different concepts and also tools in order to enable that effective communication that soon people realized it could actually be its own dedicated person or a team because it would require a whole new set of competencies that neither developers nor operations could cover in their own roles. And that's how DevOps kind of evolved. So what does DevOps actually do and what is these roles, tasks and responsibilities? So by now you realize this is the intermediary person or team between developers and IT operations. So basically DevOps engineer has to have some of the competencies and technical know-how of the developer as well as IT operations. And this know-how then makes it much easier for them to understand how this handing over of the application should work the most effectively. So they have a subset of skills on both sides, so to say. And this subset of skills make them able to communicate with both sides. So developers don't have to talk directly to operations, they can talk to DevOps because DevOps speak the same language. Because DevOps have a common language with the developers. As well as on the other side, DevOps has the common language with operations so they can kind of transfer that message to the operations much easier. However, and that is the reason why actually DevOps became its own thing, is that in addition to this subset of skills on both sides, DevOps has evolved to have its own specific unique skills and technical know-how on top of all that. And that skill set and know-how encompasses the DevOps tools that we know today. Most important, the core competency being building continuous integration, continuous delivery, or continuous deployment pipelines to make the process of transitioning the ready application to the release process, as well as some other technologies like Docker and Kubernetes to make the whole transitioning process even easier and more effective. So now that we've painted the whole picture and saw the evolvement and need for DevOps skills and some of its responsibilities, you should have a much better picture of how DevOps actually fits in the whole application development deployment process. Now, one thing that heavily influences the speed and the overall process of how software development and delivery actually happens inside an organization is the methodology, or the way that organization is actually developing the applications. What do I mean by that? Traditionally, there was this concept or a methodology of developing software called Waterfall Method. So Waterfall basically would mean, again, if we go back to the example of Facebook, let's say if the team was developing Facebook from scratch, the very first features, they would make a plan of how the application or how the Facebook application would look like with a list of every possible feature, the messaging, events, creating groups and pages and uploading pictures. So basically every specific feature listed and documented. Then a development team would take that huge list of application features and their documentation of how the business people envisioned it and start developing one feature at a time. So developers would go for a month basically just coding and adding new features and new functionalities. And once the development process of the whole entire application was done, the application would then go to the testing department. So testing department would go through each and every feature one by one and test their functionality, do load testing, do performance testing, and so on. Of course, they would find some bugs or some mismatches, so to say, between the documentation and the execution or the implementation of the features. They would send those improvement tasks back to the development team. Development team would go through each one of the improvement tasks on the list. Again, takes a month to improve the application, transfer it to the testing department. They would go through the same cycle of testing everything. And obviously this would produce a couple of cycles. And once the testing and development was completed, they would push the application over to the operations saying, here's the application, it's tested, you can now deploy that. So operations team will create these huge preparation tasks and work a couple of months or maybe again years in order to prepare the infrastructure to run the whole application. Obviously, some problems would arise because some parts of the application wouldn't run. There would be, again, back and forth with the development team and so on. So maybe after a couple of years, the application was ready and deployed and running. Now, this may sound like a tedious, long, and very ineffective process, and it was and is in most of the cases, especially when developing such complex applications, especially considering that the application development or features may evolve over time based on new demands or maybe what the users want, etc. And obviously a lot of companies realized that this method was ineffective in a lot of ways because it created so many places of failure along the process and so many opportunities for miscommunications and misunderstandings between the teams and not allow for quick and fast feedback. So as an alternative to the waterfall method, a very extreme methodology was developed, which you probably heard of, which is called Agile methodology for software development, which is actually pretty popular and is becoming increasingly popular across organizations and companies. And the main benefit or the thing that it solves is the speed of development, testing, and deploying cycles. So basically, instead of just waiting there to develop the whole application start to finish by checking off each feature and bug fix and so on, basically each new feature gets tested, deployed, and there's an immediate feedback if there is some bug in that feature or if the deployment doesn't work, etc. And the Agile methodology actually allows for a more dynamic, fast, and also easily changeable development and deployment process. And since Agile is just a methodology or a framework that just tells you, so to say, what are the good practices and efficient ways to do things, it has specific implementations of that framework. One of them being Scrum, and another one is Kanban. You probably also heard of them. And depending on the company and the team and their needs, they may be working with one of the frameworks. However, the important concept to take away here is that Agile basically is at the heart and at the core of the continuous integration and continuous delivery process, which has become the thing that a lot of companies strive towards in order to make their software development and delivery processes much more efficient. And the Agile methodology introduction or adoption in so many companies has actually supported the need for DevOps tasks, because DevOps is actually implementing the best practices or some of the best practices that Agile framework introduces. As I said, at the core of DevOps is continuous integration, continuous delivery or deployment in order to make sure that each feature and bug fix is released as fast as possible, as well as automation tools to make the process faster by replacing the human tasks with automated tools to make the process faster. Now, as I mentioned, this is a very high-level overview of how all these concepts fit together and how it all works. It's a big picture analysis so that you understand how this all comes together. Throughout this bootcamp, however, we will go and zoom in into each part of this cycle, so to say, and understand these parts in more detail and learn the concepts of continuous integration, continuous deployment, and so on along the way. And of course, learning all the concepts and tools necessary from the DevOps perspective.